guys, welcome back to Mathematics. Today we are going to talk about scientific notation. But let's start answering this question. Why is it useful? Why do we need it? So we need it in order to express very big or very small numbers in a more compressed way. It looks more organized and it's also going to allow us to identify how big or how small actually the numbers are without having to count how many digits it has or how many zeros. So for example, this is the measure of an animal cell diameter. Notice that it's very small. So we would have to count how many zeros it has to have an idea about the measure of this. So we express it as 1 times 10 to the minus 5. And this is going to be way faster to identify. Or for example, this one, this is the speed of light. So it's easier for us if we just write it as 3 times 10 to the power of 8 meters per second. So we know that it's a 3 followed by 8 zeros. And finally, this is the space that a modern solitary game takes on your computer. That we better write it as 1.8 times 10 to the 8 bytes. But of course, we have some standards. For example, we know that micro is 10 to the minus 6. So we could also write this as 10 micrometers. And since it's very common to talk about micrometers when talking about cells, virus, or something very small, then this becomes very useful in order for you to imagine what is the actual size of those. Or for example, in this one, we know that giga is 10 to the 9. So we could just write this as 0.18 gigabytes. And this is actually easier for you to understand, right? But in this video, we are not going to talk about these letters here. We are just going to talk about this notation. So we are going to learn how to convert from a normal number to this notation here. So let's see how it works. We basically need to express each number as this notation here. K, it has to be a number between 1 and 10. 10 not included. So it could be 9.9, for example, or 9.98, that kind of numbers. It could have more than one decimal place. It's not a problem. It's just that it should be between 1 and 10. And the power of 10, it has to be an integer. It could be positive or negative. Negative for small numbers, positive for big numbers. So for example, this one is a big number. This results of multiplying 6 times 100,000 because it has 5 zeros. So what we are going to do is basically write this 100,000 as a power. 6 times 10 to the power of 5. Because every time that we multiply a 10, we add a 0. So since they are 5 zeros, we just need to write the 5 as a power. So 600,000 is the same as 6 times 10 to the power of 5. Let's see what happens with the small numbers. We need to count how many spaces we would have to move the decimal point in order to make this a number between 1 and 10. The point should be here. And we have moved 1, 2, 3, 4, and 5 spaces. So that means this is going to be 7 times 10 to the power of minus 5 because we are talking about dividing the 7 by 10 5 times. It's making smaller and smaller. Notice how small this decimal is. If you want to see it in a different perspective, you could say the number is going to be 6. How many spaces do I have to move it to become the given number? So we moved 1, 2, 3, 4, 5. Then the power has to be 5. In this case, it was 7. How many places we need to move it to convert it into the given number? 1, 2, 3, 4, 5, 2. But in this case, we move it to the left. So the power is going to be minus 5. That's another way to see it. In this case, notice we don't actually have zeros. The number is going to be 7 point something because it has to be in between 1 and 10. So we are going to have to move 1, 2, 3, 4, 5, 6, 7, 8 places the decimal point. So it's going to be 7.975256662 times 10 to the 8 because it was 8 places that we moved the decimal point. But this doesn't make sense, right? Because we wanted to write it in a compressed way, and this is actually longer than the original. So when using scientific notation for this kind of numbers, we actually are going to find an approximation. So 7.97, we could cut it, for example, to 2 decimal places. It would be, this 5 makes this to go up, so we could say this is 7.98 times 10 to the 8th power. In this case, we are using 3 significant figures, and this one is part of the rounding. If you are not sure about what significant figures are, go and check the video that I leave you in the description about significant figures, and this is going to become clearer. Let's see what happens when we have the opposite. We are given the number in scientific notation, and we need to find the actual value of the number. So in this case, it says 2.3 times 10 to the minus 5. So we know that we are going to have to move the decimal point to the left. So it was initially here, so we move it 1, 2, 3, 4, and 5 steps. And what we are going to do with that? Well, we are just going to fill with zeros. So notice that 1, 2, 3, 4, 5 places the decimal point was moved, and we have the original number, 0.000023. So a pretty small number. Let's see, for example, this one. This one is multiplying, so the number gets bigger. So 6 and 4. We need to move it 7 places. 1, 2, 3, 4, 5, 6, 7 places. You see it? 1, 2, 3, 4, 5, 6, 7 places. So this is going to be the final number. We can put the commas so we can identify actually what number is that. It's 64 millions. 6.4 times 10 to the power of 7 is actually 64 millions. And finally this one, 1.5, and we need to move it to the left 2 places, 1 and 2 places. So it's going to be 0.015. Notice when the power is actually small, I think it's just easier to express it in the normal way. This could be the result of operations between scientific notation. So at the end, you could go back to the normal form and check the number. It's actually easier to understand in this way, 0.015. Okay guys, now it's your time to practice. On the left, you have numbers given in the scientific notation. Write the actual value of those numbers. And on the right, you have some numbers written in the normal notation, so please write it in the scientific notation. Please pause the video, try to do them, and then come back for the answers so you can check if you answered them correctly. Okay, let's check these ones. So we need to move the decimal point 4 places, so 0.00072. Let's check this one. We need to move it to the right 7 places. 1, 2, 3, 4, 5, 6, 7. 7 places. So the number is 93,240,000. In this one, we need to move it to the left. So 0.001. Notice that since I have to move it 3 places, then I should put 2 extra zeros after the decimal point. So 0.00125. Now let's check the second part. So this, it should be 7.9 because it has to be between 1 and 10. And then we count how many places we moved. 1, 2, 3, 4, 5, 6, 7. So to the power of 7. Okay, for this one, let's see how many places we need to move it from the 1.5. 1, 2, 3, 4, 5. 5 to the left, so minus 5. And then this would be 4.43. I'm going to round the last 3 times 10 to the, let's see, 1, 2, 3, 4, 5 to the minus 5. Okay guys, I hope it was pretty useful. Don't forget to subscribe and do your own lessons with me if you want. Okay guys, bye bye, see you next time.